Hey guys, welcome back to my YouTube channel, and in this video I'm going to show you how you can write a Verilog code for a half adder circuit. So we'll be using EDA Playground. So here you have to select the simulator. For time being I'm choosing iCarus Verilog, that is a free simulator. If you have your university email, you also get access to commercial simulators. So I'll use this, and then here you have to tick this option, that is EP wave after run. So this is basically a waveform window tool in which you can test the design using the test bench. So this will basically dump the VCD, and this EP wave will open the VCD file. So now in half adder we have two inputs and two outputs. So I'm gonna name this module as half adder, and then we have two inputs, A comma B, and then we have two outputs, that is some carry. So now I'll assign the output sum. So sum is nothing but XOR of A and B. So this is the XOR notation, and carry is basically AND of both the inputs. And I will end the module here. So now I'll write the test bench code. Module TB half adder. So I'll declare a register, that is A. I'll declare another register, that is B, and the outputs are my wires, that is sum and carry. So now now I have to connect the test bench module to the design code. So for that I have to instantiate my design module and create an instance. So I'll make this design under test. So now to connect signals, so this is my first signal. So I'm gonna use dot A, and in the parentheses you type in A, that is this signal right here. So for B it's B, and for dot sum, and for dot carry, it's carry. So yeah, now we have successfully connected both of these modules. So now I'll create an initial, begin, end block. So I'll write test cases. So when A is equal to 0, B is equal to 0 after 10 nanoseconds. So I'll change this to 1, and I'll keep the B as 0. So this is my second test vector. So in this test vector I'll keep both of these as 1. Okay, I think these many test vectors are fine for now. So I'm gonna have another initial begin block. So in this block I'll just dump the VCD file. So this is important when you are using EDA Playground. Dump.vcd, and I'm gonna also dump all the variables. Yes, I'm gonna now end the module. Now let's try saving the code. So here I'll include $finish so that the simulation ends when this statement is called out. Okay, so now if you see the waveform window, this is when A and B are 0 0, so we have sum and carry as 0. When one of it is 1, we have sum as 1, and when both of them are 1, we have sum as 0 and carry as 1. So this proves the working of the circuit. So yeah, thank you guys.